Hello everyone, welcome to this video, and in today's first video we're going to look over one variable inequalities. I'm going to be going through this as if it's a review because for my students in this year it is a review. If you're watching this for your first lesson, you solve these just like regular equations except in one type of situation. So for example, let's look at number 1. If we were to solve this inequality and we're trying to solve it for x, we need x by itself, so we'll add 9 to both sides to cancel the 9 out. That'll make a 27 on the right, and we'll copy everything else, which is the 3x, the less than or equal to, and then the new number 27. To get x by itself, we need to remove the 3. 3 is multiplying x. To remove the 3, we need to divide by 3 on both sides. So that'll leave us with x is less than or equal to 27 divided by 3. 3 fits into 27 a whole 9 times. And we have the inequality x is less than or equal to 9. That's a positive 9, so let me put a dot, and we'll fill in that dot because if we are equal to, you fill in. Now we just need to decide which x's are going to be less than 9. Are the ones that are less than 9 numbers like 0? Would 0 be something? Would 0 be less than 9? Or would I pick numbers on the right side, which are like 10? Is 10 less than or equal to 9? Well, 10's not. 10 is bigger than 9. It's greater than, so it's not that one. 0 is the right type of number. What that tells us is that every number that's on the same side of this line as 0, that's on the same side of the dot as 0, will be a solution to the original inequality. And we can check that. So let me just pick negative 8. Let's make a negative 8, and let's copy the original inequality. That's going to go for x. I have 3x minus 9 less than 18. So 3 times x minus 9 less than equal to 18. 3 times negative 8 would be negative 24 minus 9 less than equal to 18. All right, so negative 24, that's negative. Negative 9, that's negative. Together, that makes negative 33 is less than or equal to 18. And is that true? Well, I think that a negative number is smaller than a positive number. That makes sense to me. So yes, it is true, which means we shaded the correct side of our graph. I'll do one more example. And this example is going to be the type that can be different. With negative 0.3p minus 2.1 is less than or equal to negative 3.6. We'll start this off the same way, which is to remove the constants, 2.1, which means we add 2.1. Because it was negative, we will add it to remove it. Negative 3.6 plus 2.1 will still be a negative. It'll be negative 1.5 is less than or equal to negative 0.3p. We need to remove the negative sign, and we need to remove the 0.3. We can do both of those things at the same time by dividing by a negative 0.3. And here's the only thing that's going to be different. It's not that we're dividing by 0.3, it's that whenever you have an inequality and you divide by a negative number, you are going to have to, in the next step, change the direction the sign points. It was saying less than or equal to, now the sign says greater than or equal to. P is now on the greater than side because we're changing the signs of all the numbers when we divide by this negative one. So we'll do the division like normal. 2 negatives make a positive. 15 divided by 3 is a number 5. So our answer is P is greater than or equal to 5. Let's find the number 5. We're going to fill it in with a closed dot because this is equal to, or it's or equal to. Or equal to means you're going to graph with a closed dot. P is going to be greater than or equal to 5. That means I need to shade the numbers on the number line that are bigger than 5. We can check our answer again. Since this one has decimals, I want to pick an easy number to check. Like, let's pick the number 10. Negative 0.3 times 10 minus 2.1 less than or equal to negative 3.6. A decimal times a 10 will shift the decimal over one space, so I'll get negative 3 minus 2.1 less than or equal to negative 3.6. I have a negative on the left and another negative on the left. Together they're going to make something more negative, like 5.1 is less than or equal to negative 3.6. Would you say that negative 5 is more negative than negative 3.6? I would, so we did this correctly and we shaded on the right side. The only thing that we had to remember that's different is when you divide by a negative, in this step, you have to change the way the inequality is pointing. Go ahead and try B and C on your own, and I'll show you the answer in a bit. But pause the video, try them right now. Okay, there are my answers for the two questions. For problem B, I found that W was less than negative 6. For problem C, I found that B was greater than negative 6. So in C, I'm pointing towards the right. In question B, the line should point towards the left. In question C, you did have to change the sign, the direction the inequality pointed, unless you added 1/2 B to the other side as your first step.